In this video, I'm going to be covering the DownUnderCTF blockchain challenges from 2023. The first one we're going to cover in this video is 8545, which is really the beginner challenge to try and warm us up to connect to the infrastructure. There should be 4 videos covering each of the 4 challenges, so let's go ahead and get started with this beginner challenge. So this beginner challenge is literally just warming up. Let's get you started and connected to the infra and make sure that you can connect okay. Your challenge is to ensure that the isSold function returns true. So this is an isolated challenge, so we can go ahead and open up this unique link that we have been generated for our team. And we can see that the contract code is here on the left, and we can also download it here from CTFD. We get some information as well, so the challenge name, what the goal is, the status of the challenge, the player balance, so the player wallet that you are generated is preloaded with some currency. We get the wallet address, so the public address. We have the private key for the wallet. We have the contract address of where the contract is deployed at on this blockchain. We have the block time, which is the time in seconds in between when blocks are created, but 0 means that it's just instant, so on demand. Whenever there's a transaction that's sent through, a new block will be created. This is the RPC URL. And this is what we use to actually connect to the JSON API of the blockchain. So there's a node running that is hosting the blockchain. So this is how we can interact with it. And then the chain ID is just the ID that identifies the chain, which is 31337. So how do we actually go ahead and start getting connected to the blockchain? And this is a great question. It's kind of hard. As part of the challenge itself is to make sure that you can connect and work out how to do that. There's a few different ways you can do it. You could use the Remix IDE, which a lot of beginners use, and that's a really good start, and it kind of gets you understanding how the blockchain works, how compiling Solidity files work, and how to interact with all of them. However, I prefer more scriptable languages rather than Remix, which is kind of more of a UI. So there's a couple other things you could use. There is web3.py, which is a Web3 library, which is used to interact with the blockchain through a Python library. There's ethers.js, which is the kind of same thing, another scriptable language, but written in JavaScript or TypeScript. You could also use Foundry, and Foundry is a Rust-based language, which is used for smart contract development and testing. You could do all your scripting and testing there, and you don't have to leave the Solidity language, so that's also pretty cool. But today what I'm going to be using is Hardhat, and the reason I'm going to be using Hardhat is that it's built on top of ethers.js, which is a JavaScript framework, which I mentioned before, but it also does the compiling for us as well. And Hardhat is actually also used for smart contract development and testing. So that'll be really handy for us, so we can just compile the contracts in our attacking contracts, and then we can also have the scriptable element to it as well using ethers.js. So let's go ahead and get started. In this video, we're going to set up the Hardhat project, and then we're going to interact with the blockchain. So before we actually get into the challenge of what we need to do, let's just set up our environment first. So I've got an empty kind of directory here, and what I'm going to do is initialize a new Hardhat project so that we can start everything from fresh. So the first thing I'm going to do is zoom in. The first thing I'm going to do is do npm init-y, and that's just going to initialize my new kind of folder. And then I'm going to do npm install save dev Hardhat. This may take a little while because it's just installing all of Hardhat's dependencies and all this kind of stuff, so it might be back in a little bit. But this is going to just firstly get the Hardhat framework onto our system. So we'll be back when this is done. Okay, so now that we've got this installed, we're going to run npx hardhat, which is going to initialize the project. Now, what I'm going to do is, because we're not actually we're not doing any smart contract development, we're just doing testing, really. I'm going to create an empty hardhat config.js, and this will literally just do that. Install this hardhat config.js. Now, what I want to do is also make sure I can write this in TypeScript and also use ethers.js. So I'm going to install one of these kind of plugins called the Hardhat Toolbox. So this is the installation dependency that we need, the Nomic Foundation Hardhat Toolbox. And this will install everything that we need. Now, in the background, while this is happening, I'm actually going to update everything so we can use TypeScript. So TypeScript, it just gives us types and makes it all go away. Makes it all nice and easy to work with. So the first thing we need to do is just following this tutorial here from Hardhat of how to create a TypeScript TypeScript project. We need to move the Hardhat config from JS to TS. And I'm also just going to copy all of this and update my hardhat.config. We're going to move hardhat config from JS to TS. And we're also going to install this or add this TS config. So touch tsconfig.json and just paste this in. Have I updated this? Yeah, okay. So now we're all good to go. We have our Hardhat config set up. Now, what is this? This is just basically telling Hardhat how to run itself. So the only thing I want to use from Hardhat is its compiler. So we just want to tell it to use Solidity version 0.8.19 because that's the version that's used in the smart contracts. And we can see that when we go to the blockchain challenge, we can see that this is using 0.8.19. It's actually using, use this as a minimum really, but we'll use this for now because this is how it will work. Okay, so now our environment's actually set up. So we can go ahead and start coding our solution. So the first thing that I want to do is actually make sure that we can compile this. So compile the contract. So we're going to make a new directory called scripts and also make a directory called contracts. And scripts is going to be where our solution script lives, and the contract is going to be where our contracts live. So we're going to create a new file here called 8545.sol. And this is this contract here, which is this challenge. And we're just going to copy this contract and we're going to go through it now. So this is quite a simple challenge. All we need to do is ensure that this is solved function returns true. So let's work backwards and see where this is being where we can make this return true. So we can see this is an external view function. So all it is doing is returning the uSolvedIt variable. And this state variable, which is defined up here, is a Boolean, it's public, and its default value is set to false. So when this contract is deployed, it'll be set to false, which makes sense because we'll want to do something to make it return to true. So how do we make it return true? So we can also see that this variable is set in this solve the challenge function. And this solve the challenge function takes one parameter, which is a string, and that's called answer. And when we call it, the uSolvedIt variable, which is a Boolean, is set to the outcome of this Boolean condition, which is asking whether the kekak 256 of the answer is equal to the kekak 256 of use this. So answer is our parameter here, and use this is something we haven't seen yet. So this kekak256 is basically hashing the string, and it's checking if the hash of each individual variable, the use this variable and the answer parameter here, is the same. So in essence, it's actually asking, are these two string values the same? So essentially we need answer to be equal to use this. Okay, so now continuing to work backwards, what is use this? So use this is another string variable that is set, but it actually isn't set to anything at the very start. It is set at the constructor level instead of just built into the contract itself. And this is a private variable, so we can't read it directly, or it isn't easily exposed through the contract interface. So we have this use this variable, which is set to some string in the constructor at the very start or initialization of this smart contract when it's deployed. So when it's deployed, it'll be deployed with some value that sets this value. So how do we read this use this? Because we want to understand what this string is to then pass it into the solve the challenge function. Well, it's pretty straightforward. There's a function directly here that says read the string here, and this read the string here will return use this. So once we get use this, we can just pass that into the solve the challenge, and that'll solve the challenge, which will return is solved is true. So let's compile this, and we can do this with npx hardhat compile, and this will generate some nice typings and stuff. And this is essentially why we're using Hardhat, so we don't have to do Solidity and other things like that, and any changes kind of come in pretty nice and cleanly. So we're going to go into scripts and make a new solve script called 8545.ts. And this is where all the magic's going to happen. Now I'm going to copy paste some boilerplate here, and don't be kind of scared because there's a lot of boilerplate. This is just kind of a lot of convenience functions, not actually doing any solutions here. So let's put in some of the first stuff. So first thing here, we're going to import ethers from Hardhat. This is the Web3 library that's really handy, and it's written in JS, so we're going to be using to interact with the blockchain. We're putting in our API URL here. So this is the URL that the DownUnderCTF challenge gave us, which is up here. And we're just going to type the response that we get from the API URL. Again, you don't need to do all this. This is just so we can script the entire solution without having to copy details from the helper page or like the challenge page. This first function I'm going to paste in here is called getChallengeDetails, and this simply will call the API URL at /challenge that will return all these challenge details. So that is essentially returning all these details here. This next helper function is just another function to get the flag. So when we want to get the flag, once the challenge is solved, we again call the API URL challenge solve, and we wait for that data to come back. Again, this is just so we don't have to click the get flag button here, which is failing at the moment because we haven't solved the challenge. We then have the main function. This is where the code is going to run. So the first thing we're going to do is get the details from this get challenge details and get all the challenge details. We're going to set the challenge provider. So this is where we create a new JSON RPC provider based on the RPC URL that's been given to us in the challenge details. And so this is basically telling ethers how to interact with the blockchain and where to send all our requests. Finally, we're going to set up our player wallet. So this player wallet is going to be a new ethers wallet, and this is going to create our wallet from our private key and make sure that this is connected to the challenge provider, which is that RPC URL. Finally, we're just going to paste in our kind of entry point into this solve script. So it's just the main function that's calling it. And if there's any errors, we can catch them. So let's solve this function. All we need to do is read, again, if we go back to our contract, we need to read this string here and get whatever value is and pass it into the solve the challenge function. And then ideally is solved will return true. So how do we do this? So the first thing that we're going to do is connect to the contract. So this contract is already deployed on the blockchain. So we just want to connect to it at the address that has been provided to us. So the first thing that we're going to do is run get contract at. So we're going to get the challenge contract, and that's going to be equal to ethers.getContractAt. And we're going to define this as 8545. So this is that typing that Hardhat is helping us with. So it's telling us this is the contract that the type of contract that we're connecting to, and we're going to connect to it at this particular contract address, which has come from the details from the get challenge details, and we're going to connect to it with our player wallet. So any interactions that we do with this, we're going to interact with it with our player wallet. Okay. So then the next thing that we want to do is run the get the string, I think it's called. Read the string here. So we want to call this function. So the answer, let's just call it answer, equals, we're going to await again the challenge contract dot read the string here. So if we then log this, we should see what the answer is. So to run this, we're going to go npx hardhat run scripts 8545, and it doesn't exist. Oh, it's because I'm in the scripts directory. And we can see that the logged value is I can connect to the blockchain. So cool, we actually have the string now. We can now use that to solve the challenge. So once we've read the string, we can then go ahead and do the second part, which is to solve the challenge. One other thing I'm also going to do is, before we solve this challenge, is I'm going to create a variable called isSolved, and we're going to call the challenge contract.isSolved, and we're going to log the value is solved returned is solved. So when we run this again, we should expect this to return false. Yep, is solved return false, and here's the string. So now what we're going to do is input that and create a transaction to input this. So to do that, what we're going to do is run an await challenge contract dot solve the challenge, and we're going to pass in the string. So this string is answer. And because this is a write contract, or it's like a write function as opposed to a read function, because we're literally updating the state of the blockchain, so you solved it is being updated, we need to actually create a transaction to do this. And because this solved the challenge, Ethers.js is smart enough to know that this is a transaction, or like a write transaction. So this will return a transaction receipt. So yeah, once we've got this, we call solve the challenge with the answer. And then after that, what I want to do is immediately call the isSolved function, because ideally once this is done, once this is called, we have solved the challenge. So let's go ahead and run this. And there we go. So isSolved, return false, and now isSolved, return true. So this has updated the blockchain, and now we can go ahead and retrieve the flag. So we have our helper function here called getFlag. So we're just going to go console.log getFlag. And I think we need to await this as well, because this is an asynchronous function. So once we run this, this will be true, because we're connecting to the same contract. But there we go, we have the flag here. And also, we can also go ahead to the kind of challenge dashboard and hit get flag. Again, if we reset this challenge, we're going to get a new contract address, a new player wallet, and a new, all there's 4 values here will be updated. So let's wait for this to redeploy. There we go. So we've got our new values here, and our script should work exactly the same. So we should see false initially, and then it goes true after we send our contract, our value, and update the value, and we can update we get the flag in the return. Okay, so cool. This is the first challenge in the DUCTF challenge blockchain category. The next video, I'll be covering another please, which is a different challenge again. All right, see you later. Thanks for watching.